Density. Density is defined as mass per unit volume. We can write the equation of density as ρ equals m divided by v, where ρ is density in kilogram per cubic meter or grams per cubic centimeters. M is mass in kilogram or gram. V is volume in cubic meters or cubic centimeters. Density is specific value for each material, meaning that same material will always have the same density. For example, let's say we know an unknown material with a mass of 2.41 kilogram and its volume of 125 cubic centimeters. We know the densities of gold, aluminum, and silver as shown in the table. To determine which material our unknown sample is made of, we can use the equation density equals mass divided by volume. We must change 2.41 kilograms to grams, as 2.41 times 1000 is equal to 2410 grams. So, the density of unknown material equals 2410 grams divided by 125 cubic centimeters equals 19.3 grams per cubic centimeters. Therefore, our unknown sample is made of gold. The density of an object can explain whether it will float or sink in a liquid. If the density of an object is more than the density of liquid, the object will sink. If the density of an object is less than the density of the liquid, the object will float. For example, a block of aluminum will sink and settle to the bottom of a liquid, which shows that its density is more than the liquid. A block of ice will float at the surface of liquid, but will be totally submerged, which shows that its density is equal to the liquid. A block of cork will float at the surface of a liquid, with some of it submerged, which shows that its density is less than the liquid. Experiment to investigate the density of a regular object. 1. We measure the mass of a regular object using a scale balance or a spring balance. If we use a scale balance, we will get the mass. If we use a spring balance or Newton meter, we will get the weight. We can find the mass by dividing the weight by 9.8. 2. We find the volume of a regular object by measuring its dimensions and calculating the volume using the formula. For example, a cube, we measure all sides by a ruler. Then we calculate its volume using V equals side cubed. A cuboid, we measure the length L, width W, and height H by a ruler. Then we calculate its volume using V equals length times width times height. A cylinder, we measure the height H using a ruler. To measure its diameter D, we use a ruler and wooden blocks as shown. We view from the top view and measure the length between blocks at different positions, as shown, to checking that they are equal. To calculate the radius R of the cylinder, we divide the diameter by 2. Then we calculate the volume of cylinder using V equals pi r squared h. A sphere, we measure the radius R by the same method as the cylinder. To calculate the volume of the sphere, we use V equals 4 over 3 pi r cubed. We should measure each length at different positions and find the average to get an accurate value. And view the scale at a perpendicular angle to avoid parallax error. 3. We can calculate the density of each object using ρ equals m divided by v. Experiment to investigate the density of an irregular object that sinks in water, such as a stone. 1. We measure the mass of a stone using a scale balance, or a spring balance. 2. We measure the volume of a stone using a measuring cylinder, as follows. Fill the measuring cylinder with water. Read the initial volume, V1, by viewing the scale at perpendicular angle at the bottom of the meniscus as shown. Carefully place the stone into the water. The water level rise, as shown. Read the final volume, V2, by viewing the scale at a perpendicular angle at the bottom of the meniscus. The volume of the stone is the final volume, V2, minus the initial volume, V1. 3. We can calculate the density of a stone using ρ equals m divided by v. How to determine the volume of a piece of wood that floats in the water, such as a cork. Fill a measuring cylinder with water. Tie a thread to a stone, and place it into the water. Read the initial value, V1, by viewing the scale at a perpendicular angle at the bottom of the meniscus as shown. Remove the stone from the measuring cylinder by lifting it up by the thread. Tie the cork to the end of the thread. Lower the cork and stone into the measuring cylinder. Read the final volume, V2, by viewing the scale at a perpendicular angle at the bottom of the meniscus, as shown. The volume of the cork is the final volume, V2, minus the initial volume, V1. I hope you found this video helpful. If you did, I would be grateful if you would subscribe to my channel, share this video with your friends, and leave a positive comment. Your support will help me to continue making videos and encourage me to create new content. Thank you.